Question 5, more organic chemistry. In this case we are going to outline a mechanism for the reaction between 2-methyl-butene and hydrogen bromide, and they form two different products, a minor and a major product. Now this depends on the stability of the intermediate carbocation. Now the carbocation we can see is formed here, and what happens in this first step, the first calorie, you must remember the alkene double bond breaks and moves towards the delta positive hydrogen of this polar HBr bond, and that forces the bond between the hydrogen and the bromine to break. The bromine collects this pair of electrons. Remember, the curly arrow shows the movement of a pair of electrons. We can see that pair of electrons there in the Br-. The positive charge of the carbocation is now on this C+, which is surrounded by 3 carbons, and that's a highly stable carbocation intermediate, more likely to form. And the Br- attacks, excuse the scrubbings out, and forms this new bond with the Cbr, and the reaction is finished. The secondary carbocation produces this product here. A less stable intermediate, plus would be on this carbon, and the Br- would move towards this C+. Now just clarifying why the two products are formed in different amounts. Well, the major product is the tertiary carbocation, which is more stable, and so tertiary is more stable than the secondary, and therefore that is why it is the major product. So question 6, a different reaction. This is aqueous trichloroethanoic acid and magnesium ribbon. This is an ionic equation for that reaction. This is the acid, this is magnesium, making magnesium ions, and hydrogen as the byproduct. Now this is an accurate way of measuring enthalpy change. You would have done this in class if you were present in that particular lesson of measuring enthalpy change. What happens is we measure the aqueous trichloroethanoic acid, its temperature before adding magnesium. We add the magnesium at 4 minutes. We then measure the temperature until the 14th minute. The data has been plotted. We've got an extrapolation curve to the 4th minute to see the initial temperature of 23. We then extrapolate that line, a line of best fit. This really estimates the heat loss that's from the 4th minute, and this measures the maximum temperature of the solution at 4 minutes. What we're going to do next is look at how we use that data. So what we do here, we're going to use Q, which is heat change, is the mass of the solution being heated, times by the heat capacity, times by the change in temperature. Change in temperature is calculated already. The mass being heated is 10, that is, or 10.0. We know that the density of water in which the trichloroethanoic is contained, it's aqueous, remember, is 1 gram per cubic centimetre, so 10 cubic centimetres becomes 10 grams. 4.18 is the heat capacity of water, times by 17, that's the heat of the reaction, specifically in the reaction, which comes to this value here. We're then going to work out the moles of magnesium that reacted, so we get enthalpy change, which is in joules per mole of a substance reacting. So here I'm working out the mass of magnesium in grams rather than milligrams, so that conversion there is 0.24 grams. It's divided by 1,000 to convert milligrams to grams. Then we're going to work out a mole, so divide by around 24.3 for magnesium, and that's the answer of moles. Enthalpy change is joules divided by moles, so that's the value there, 71,923.07, minus charge because it was exothermic, there was a rise in temperature, hence exothermic. And then in terms of significant figures, this is inappropriate. We look at all the data. The temperature change was at 17 or 17.0. That's 3 sig fig for the mass of magnesium, that's 3 sig fig for the trichloroethanoic acid. You've got to also analyse that and think about significant figures, and which is most appropriate. We accepted these two answers in our mark scheme. You could, if you were using it, it's 2 sig fig for 17 or 3 sig fig for the 17.0. But look at all the data. What's the most appropriate number of significant figures? You need to go to the lowest amount of significant figures, and that's your final answer, and that's what it should be recorded in.